Good evening, everyone. On the behalf of Team Dentist Channel Online, I would like to extend a very warm welcome to all of you. I'm Dr. Aditi Mishra, and I'll be the host for today's session on the topic Zirconia, a Leap Ahead by Mr. Bilas. So before starting with the session, I have few housekeeping notes to make. If you have any doubts during the session, you can drop your questions in the question and answer box, and each and every question will be taken up at the end of the session. If you have joined us from Facebook and YouTube Live, you can ask us questions by commenting, and we will be answering them at the end of the session. So without further ado, I would like to introduce our today's speaker to everyone. Mr. Balazs Vait is the Business Development Manager at Dental Direct GmbH CAD/CAM Specialist. Since 2010, he has been the all-rounder dental technician in conventional techniques. Since 2015, he has been the sales representative and product manager for Vita, 3Shape AS, and Roland DG. Since 2017, he has been the specialist in Zirconia and CAD/CAM systems. Since 2018, at Direct Dental as customer service specialist. Over to you, Mr. Bilas. Mr. Bilas, can you hear me?
Yeah, thank you very much. Yeah. Do you hear me well now, right?
Yes, absolutely.
Okay, I will start my presentation. Please give me your feedback also if you see that correctly. You see me correct? You hear me correct?
Yes, absolutely. Right? Please go ahead.
Perfect. Thank you very much. Thank you for the introduction. It's a pleasure to be here again since last week. Last week we spoke about the material topic from the point of view of the dentist, and this week I wish to introduce our company and our material portfolio from the aspect of dental technician side. We as a Dental Direct, we are a complete manufacturer for CAD/CAM and for the dental industry. It means we are known as a zirconia manufacturer from the past, but since today we are everywhere worldwide in the dental business, and we are developing and manufacturing not just zirconia materials, but also a huge amount polymer materials, and also in the last time implant components. It means we have a really huge know-how about the material, and next to that also about the dental technologies. It means software and the machines, scanners and milling machines. And next to that, which I see a huge advantage, we have also in Germany a milling center, where we use also our materials, our technologies, also our implant components. It means it's a huge advantage for us, because we are not just producing and selling our materials, but we are working directly with our materials too. Just a few words about my person. I'm a dental technician too, and I'm working as a product manager and business development manager since 2018 at the Dental Direct company, and I offer usually product trainings, webinars like this one for technicians. So after the webinar, in case of you have any questions about our materials or our technologies, do not hesitate to find me, to contact me directly. As I mentioned, we have for the complete digital workflow in our product portfolio different products, which means from the material, from the zirconia material till the implant components, and also the complete equipment. It means from intraoral scanner to milling machines. We have for every laboratory, for every practice laboratory or every dentist a solution, and we are offering always a complete solution, a complete workflow. This I find a really important thing, because in that way, as a dentist, as a dental technician, you can be always sure that all of the materials, all of the techniques, what you are using in your laboratory are working together. They are always a part of a complete workflow. Now let's turn to the zirconia topic, to the zirconia materials. Of course, nowadays it's more and more the question which are the actual way into the materials, which are nowadays the popular materials, or which is our future material. What is our future in the dentistry, in the dental technology? The question is, first of all, that we are still in the layered techniques, or we are going to full contour direction. That analytics, that example, it's a bit older examples here, but we are analyzed also in Germany, the market, and also in the USA. And I have to say, in Germany, we are still more conventional technical people. It means we are still more on the layered zirconia, but we see that everything goes in the full contour zirconia direction. And for example, in the USA, where they use all the new products, all the new materials immediately, if it's available on the market, we see clearly that in the USA, on that market, almost 80% of the zirconia restorations are made from full contour materials. It means for full contour materials, we have to adapt our techniques to the materials. It means we have different requirements for the materials and different challenges what we have to solve with the full contour material. And of course, there is always a question: which type of zirconia material should we use to reach the proper aesthetic, the proper functionality, which is the best and suitable material for us. Of course, in our material portfolio from Dental Direct, we have a complete range of the zirconia materials. It means we have conventional type of, let's say, conventional type of zirconia materials. It means we have still products which is possible to layer, which is where is the layering techniques are still necessary to have. But of course, in our focus, we have a new group of zirconia materials. This is our cube type of zirconia materials, where we put really high focus on the aesthetic and the translucency. It means the translucency is always important, but and the aesthetic. But next to that, we have to check always different kind of physical properties of material. It means the flexural strength of the materials, and of course the different kind of masking effects, because because the high translucent material it's also not for every indication the proper material. So we still not forget to use in some cases the more opaque and more stable materials. But after that, later on, I will come back to this point once again. Of course, now I wish to introduce our full contour zirconia system. It means the Cube 1 and the Cube X materials, which are both of them are available in a multi-layer form, and I wish to compare that with a well-known Emacs product, which is a well-known product and a popular product. And why I wish to introduce that for you, because we are becoming also more and more, and became more and more a request to develop some materials which is comparable with Emacs materials. And in that aspect, we analyzed our materials, and we figure out that today with the Cube X and the Cube 1 materials, with the zirconia materials, we can reach same aesthetic or even better aesthetic like Emacs, and which is a really important thing, that with smaller wall thickness. It means we don't need anymore too much space to create a reliable and an aesthetic crown, because we know exactly the conversation between a dentist and a technician is most of the cases about the spaces. The dentist says always, yeah, I prepared so much that you can do whatever you want. We have place here. You can create in your design software what you just wish. And from the technical side, the technician, from the other hand, they are complaining always that they don't have never enough space to create their restorations. It means thanks to the zirconia materials what we have, we can reach the same aesthetic, but of course with a minimal space. It means for a single crown or even smaller bridges, 3-unit bridges, we need in most of the cases 1.5 millimeter space. It means it's more work for the dentist. They have to prepare more from the naturalities, and of course it's more material what we have to build on to have the same reliable and aesthetic restoration. Which means for an Emacs crown, for example, that 1.5 millimeter. The same we can reach from a zirconia material, from our zirconia material with 0.1 millimeter space. And a really important part next to that when we analyze the flexural strength, that with the zirconia material, we are still much higher in the stability like the Emacs material. And if we see that restorations in the long term, it will be always a much more reliable restoration made from zirconia material. Of course, why we have that nice aesthetic zirconia, and why we can, and how we could reach that translucency. There we go into the details, in the technical parts. It's belonging on the cubic phase of the material. It means we have in our Cube X and Cube 1 material more from the cubic phase and less from the tetragonal phase. It means the grain size into the inside the material are bigger. It means at the end that the light can go through the material much more easier, and as a final effect we will see more translucency. This is just visualized as in our example in a 1 millimeter milled plate. You can see the more and the bigger grain size, and how can go easier through the light into that cubic type of material. This is just the technical background. Another really important part, comparing, for example, the lithium disilicate materials. In some cases, many of the cases, we cannot avoid to grind after the sintering process the zirconia materials. It means every grinding or every grinding process after the sintering, we have to take the risk that we will get micro cracks, micro defects in the material, and of course it can go through to the complete material. So if we are not working with water cooling and really with proper tools, zirconia grinding tools, a failure we can have really easily and really fast. But there we come to another topic, and this is the fracture toughness. It means the material have a so-called K1C value, which means the fracture toughness. And this is what the zirconia, this is what our zirconia have. It means in case if we have a micro crack in the material, thanks to the transformed and metastable tetragonal grains, the crack will be stopped into the material, and it means at the end that you will not see a complete crack in the material, and the material will be still stable. And this is something what, for example, lithium disilicate don't have. In most of the cases, also in the dental industry, in zirconia material, we are speaking a lot of about megapascals, but no one's speaking about the fracture toughness, which is a really important thing. And how we do, how we know that, where we know that, because we are working with the University of Regensburg from Germany, and they are doing also some tests for us. And one of these tests are chewing simulation, so-called chewing simulation. It's a long-term stress test, for example. So they prepared a normal and average crown, and they tested like a 5-year mastication test. It means 1.2 million times they are put the normal 50 Newton average chewing force on it, and they analyzed how the zirconia crown reacted after that process. Of course, they simulated also the oral environment condition. It means conditions. It means they are heated that crown up, they are cooled that down, and it was also a stress for the material. And after that 1.2 million cycles, they saw that the material is still stable. It wasn't any cracks or damages in that crown. So therefore, we could be also sure that that these crowns will stay stable also in the long-term test. Of course, that was the physical part, the scientific part of the material. But when we speak about the new type of materials, we have to speak also about different kind of coloring concepts. Of course, with our materials, we have different kind of materials in different kind of colors. We have also multi-layer colors, we have monochrome colors, and also white colors. The new trend and the most popular materials nowadays, the multi-layer materials. And for that, we have also a multi-layer concept. It means we build our cube one monolithic type of materials in a multi-layer form. In that way, you will have 5 main colors, and between each of the main colors, main layers, I mean, you will have always a transition layer. It means the complete layers are really smooth layered into the material. So you will not see any layers or any border between the layers. But of course, when we are working with multi-layer type of material, we have different different duties about the nesting. Of course, we know for a long time the white zirconia material, and we as dental technician we used to work with the blanks like that we use the complete blank 100% or 99%. We wish to use from the blank, from the top of the until to the bottom, and also all around into the blank. This is not possible with the multi-layer material. So we have to see that the multi-layer, we have a dentin layer, which is in most of the cases, and also in our available blank heights, always different. And what we made, we fixed the incisal part, the incisal edge into the blank. So it means that doesn't matter which blanks you take, the 14, 18 or 22 millimeter, you have always the same incisal part into the blank. And why we need that? Because we have to place what you see also in our example. You have to place your crown always in that way that you will have also some part from the incisal part, but most of the crown should be placed into the dentin area. And of course, this changing always regarding of the cases. So in our example, we have a single crown, but of course, as you turn to bigger bridges, it will be a difficult part of the nesting. On that part, I will come back soon once again. I wish to mention, because this is also popular nowadays, the mixed type of multi-layer. It means that in the incisal edge you have a translucent material, for example, a 5 yttrium type of material, which is really translucent and really aesthetic. But in the body area, you have a stronger, a more opaque material. It's a nice idea. It's a good idea from the industry. Actually, we don't have these kind of products because we analyzed also our competitors, and we see that this solution to mix different kind of materials is still not reliable. It means you will have a weaker material, and not just a translucent material, but also a bit weaker material in the incisal part, and in the dentin part you have the stronger material. It could be good work it can be work really good for a single crown, but as soon as you have a bigger bridge where you have to place also the connectors between the units, between the crowns, you will have a problem. Because when you place your connector also into the incisal part, into the weaker part of the blank, in that moment your bridge is not so stable anymore, and this is what we see now as a problem with the mixed type of, or let's say 3D multi-layer materials. Of course, for that we have also a solution. I will show you that also after a few slides. So this is what I meant with the nesting. For a single crown, to place a crown into the incisal part, into the dentin area, it's not a problem. But as soon as we go into bridges, we have also problems here with the connectors. How we can place that. In which area should we place that? And this is until now not so sure with the 3D type of multi-layer materials. But as I mentioned, for that we have also a solution, because we see exactly that sometimes it's necessary. In some cases we need a strong material where we can create a complete arch. We can mill a complete full arch case from zirconia on implants, for example. But when we have a strong material, it could be never so translucent like an HT plus material. For that, we developed a so-called INCISAL X liquid, which is extra developed for a stronger material, for our Cube 1 material, which is strong enough to create a complete arch or implant case, for example. And what we done, that we created that liquid, what you can take for the incisal part in the front area, where you need really that high aesthetic, that translucency. You apply that as a liquid before the sinterization, and with that you will reach the same translucent value what you have from the HT plus materials. But it's a really important thing that using that liquid, you are much more on the safer side. It means you will apply that just on the crowns, on the incisal part of the crowns, but not on the connectors. It means your complete bridge, your complete work will still stable. You will have still the flexural strength of the material, and you don't have to take that risk what you have with the 3D type of materials. This is how it looks, for example. In our example, we took a Cube 1 multi-layer material in A2 color, and on one side, on the incisal part, in that quadrant, we took the incisal X liquid, applied on the incisal part, let the framework or the work, the bridge to complete the sinter process. And after that, finally, we have the same and exact same translucency what we can have for from a Cube X more translucent material, but without that we have to take the risk to apply that on the connector of the works. Of course, we have for the complete material portfolio our shade concept. So we have an exact recommendation in indications, also in material, and which is really important regarding always of the stability and always of the translucency. It means sometimes we have to work on implant cases or metal crowns or metal dies, or just we have a strongly discolored dye, prepared dye. Then of course we have to take a material which is not so translucent. And in that way, we have that also in our portfolio. It's a huge advantage also that for every our material, we have the same sintering circle, we have the same sintering process. So there is just one program, there is just one recommendation for the sintering process. And with that one recommendation, you can sinter all of our materials. Of course, we are speaking a lot about multi-layer materials, but we should not forget the white type of materials. There are still some cases what we cannot solve with multi-layer materials, or what we cannot reach with multi-layer materials, and there we need, of course, coloring liquids. For that, we have also a complete portfolio. It means we have universal liquids, we have effect colors, and we have specified liquids for different kind of zirconia materials. And of course, regarding that liquids and regarding the materials, we have an exact recommendation, which liquid is the proper one for the materials. And of course, they are working also with dipping technique. It's still a popular and effective process. The dipping technique. We have also the liquids for dipping techniques, or I mean, we have the liquids, the same liquids also for dipping technique, which is also suitable for a brush technique. It's depending just on you as a technician, which techniques you prefer, which technique is better suitable for you, for your process or for your workflow. And of course, at the end comes everything together. It means we have the effect colors in a liquid form. We have the dentin colors, and at the end we have our contrast, DDcontrast stain and glaze set. It means in that way we have again the complete workflow, the complete material portfolio to have and to individualize your teeth in that way. What you want, what is your requirements, or what are the requirements of your patients, of your dentist. And here is at last an example. For example, a case what you can solve easily from a white material. So, for example, in that case, you see that this is an implant case, directly screwed implant case, where the gingival part was also restored. It means we started here from a white zirconia. We had to color also the gingival part with a pink color, also some characterization. And after the sinter process and after the glazing process, the glaze process, reached our final aesthetic restoration. Really important thing, of course, just speaking a few words about the necessary processes, the sintering process. This is a really critical part because if we need color stability, color reliability during the process, we have to speak and we have to check always the sintering process. It means if we have too much energy during a sintering process, it could be at the end that our colors, our shades will be too bright, and we will have less chroma our colors. So it's really important that we pay attention also on the sintering, and we pay attention also about the proper calibration. For that and for this reason, we have always a really nice and really precise recommendation. This is the opposite of that. For example, on the first picture we saw, in case we have too much energy, we will have a brighter color. But from the other hand, when we do not have enough energy during the sintering process, our crowns will be too opaque and too dark. And it could be not just a problem of the sintering process or the sintering furnace, it could be a problem of the not proper program what you took. For example, if I filled our sintering furnace completely, the furnace is full with crowns and bridges. Of course, we need more time to reach that energy, to reach that temperature. So we have to pay attention always to choose the proper sintering process and sintering cycles. Next to that, and here's just a small comparison table, how the different materials react on the different temperatures regarding of translucency, what you see here on the upper picture, and regarding of the color. You see exactly how they lost their translucency and how they lose their color, changing just the temperature. Of course, because we know that it's a critical step also next to the zirconia producing and creating aesthetic cases. We're offering also solutions for temperature calibrations, which you will find also on our website, and not just calibration process recommendation, but also cleaning process, because it's also a really important thing. If you are working with liquids, dipping or brush technique, you have to keep your furnace chamber also clean to avoid any contaminations during the sintering process. Finally, let's speak a few words about our color and form concept. This is our stain and glaze set, DD dental direct contrast system, where we have different kind of color masses, where we can create our effect colors on the surfaces. And next to that, we have also the so-called texture masses, and which is unique in that product, that we reached and that we adapt our texture and color masses regarding to the naturalities. It means in our masses we have natural fluorescency in the material, and they are changing also regarding on the surface. It means if you take a deeper, if you take a deep and darker color, which is mostly in the deepest part of a crown, what you see here also on our example, there we don't need any fluorescence effect. But for example, for an animal mass, where in the naturalities also a high value fluorescence value possible or available or visible, there we put also our fluorescence masses. So it means at the end you will see a more aesthetic case, and just the pure glaze masses are also available in a normal form and also in an extra fluorescence form. And that one, of course, as I mentioned at the beginning, these contrast material is developed for our monolithic system, our monolithic zirconia materials. It means, of course, that this is the best option to work that in a complete system, but the contrast material is also compatible, for example, with lithium disilicate materials too. So you have to you can still combine with different kind of material the contrast stain and glaze set. Here are some example cases. For example, made from cube one multi-layer material. In that case, for a single molar crown, a more characterized crown, and the more simple one, just the glazed one. And the same also with cubics material for a more aesthetic case in the front area, also with some characterization, individualization. A really huge advantage and a nice feature of the material that, as you see, and as I mentioned, we have texture masses, we have the color ones and the glaze one. As you see, the material thickness in the texture masses are a bit thicker. It means, and this is what you see here also on the picture, it means with the texture masses you can minimal layer on a crown. Sometimes we see, especially with monolithic crowns, with full contour crowns, that after the sintering process, the technician or the dentist will figure out there are missing contact points, occlusal contact, mesial, distal contacts are missing, and this is what you can do with the texture mass. With the texture masses, you can apply like a normal ceramic. It's a let's say micro ceramic material, and you can create with that still contact points, and the material is really stable, so you can place really precise on your surface. This is what you see here again, and for example, for that case, the final restoration. On that example, you see a workflow from a sinter crown, where we glazed the half of the crown already, and the complete aesthetic glazed and stained crown, how it will look like. An important thing at the last, the behavior, the wear behavior of the monolithic zirconia. It's an also important part, because it was many years a huge topic, how we'll work the zirconia together with the antagonist, with the natural teeth. We saw that after 3 years, the surface quality of a zirconia crown could be really rough. It means it will be not so ideal for the natural antagonist tooth. We analyzed the different kind of materials. We saw that the enamel of the natural teeth has that value in the hardness, and we analyzed different kind of materials regarding that, like example, veneered ceramics, polished glazed zirconia surface, polished and glazed zirconia surface, and glazed zirconia. At the end, we saw that the best solution is basically that one when we just polish the surface, because in that way we can avoid to have that rough surface, what we saw on the scanning electron microscope picture. And in that way, we are almost on the same level, or even less on that level what the natural tooth has, what the enamel layer of a natural tooth has. So the best option will be a polished zirconia crown. After that, we took also 3 examples from our materials. We polished them, all of the crowns from different kind of materials, and we analyzed that also how they will react. Just the glazed crown, glazed by contrast material, and we saw that with our glazed, and thanks to that microstructure, micro ceramic structure, we reached the same level with our contrast material what we have in a polished crown. And of course, it was done again by the University of Regensburg, and they do that one also as an abrasion test. So we are sure that when we took our contrast glaze material, that we will, and also on our zirconia material, we will reach a really good solution for the antagonist teeth. And last but not least, as I mentioned, I have to say once again, we are offering always a complete solution. It means we are offering for our customers, for technicians, and also for dentists, a cementation system. It means this is our solid link material. Why I mention here? Because we have more and more implant restoration, and of course the implant abutments, tie bases, hybrid abutments, we have to cement also in the laboratory, and with our solid link material is also possible, so we can use that also extraorally and also intraorally. So that material is also a good solution for the laboratory and also for the dentist too, and not just for zirconia, but also for every dental material, and not just for an implant crown, but also for natural teeth is suitable. And next to that, it's really important that we have in that solid link cement system a so-called try-in set. It means the dentist or the technician can check always before the final cementation the proper dentin, white, opaque or translucent cementing material regarding of the color adaptation. So in that way we can reach at the end a really precise and a proper shade in the cemented crown, implant crown, or just a normal crown. From my side, that was it. Thank you very much for your attention. If you have a question, then just please drop it in the question box or in the chat, and I'm happy to answer your questions. Thank you very much.
Thank you so much, Mr. Balazs, for such an informative session. And so let's move on to the question and answer session. Before moving to that, I'll be introducing our organization to all the participants. And meanwhile, I request all the participants to kindly drop their questions in the question and answer box so that we can take them up one by one. I hope my presentation is visible to everyone. All right, so this is our channel, Dentist Channel Online, with the motto Healthy Smiles That Leads to Wealthy Lives. And this is our new website, DentistChannel.Online. So we have come up with a new website, and this will be catering to everyone and anyone who is associated with the dental fraternity. So kindly log into this site. And basically our organization is the first India's dental digital marketing media company, which is striving very hard to bring all the dental professionals, dental practitioners, dental technicians, and everyone who is connected to the dental fraternity under one roof and creating opportunity for everyone. And we conduct a lot of sessions, a lot of webinars, workshops every month. And if you have subscribed for our Prime membership, you can avail a lot of discounts and a lot of benefits. So I request participants who have not subscribed to our Prime membership, kindly do that ASAP. And I've provided the link in the chat box. This is one sample e-certificate which the Prime members will be receiving after the end of each webinar. Okay, so I request our participants to kindly save this number and give one WhatsApp text message on this number containing your name so that you're added to our broadcast list, and you will be updated regarding each and every upcoming event we'll be having. And if you have missed out on our live sessions, recorded videos will be available on Facebook and YouTube. You can follow us on Instagram with the handle Dentist Channel Online, and you'll be updated regarding each and every upcoming event. Okay, so moving to the question and answer session. Mr. Balazs, can you hear me?
Yeah.
Okay. So the first question that we have is from Mr. Akil. He's asking why zirconia bridges are getting break. Basically why zirconia bridges get break inside the patient's mouth whenever they're placed. Sometimes that might happen.
Yeah. I mentioned that part also in my presentation with the micro cracks. It could be that it's not a failure of the dentist. The failure could happen before the processing of the zirconia. It could be a sintering problem. It could be a grinding problem. It means after the sinter process, for example, the zirconia was grind. It get a thermal shock, or just during the glazing process, the heating and cooling phase was too short, too fast, and the material had a thermal shock. It means into the material there is already some micro cracks. Will be at the end to cement it in the patient mouth. That micro cracks can develop more and more, and finally at the end it will break into the patient mouth. This could be one failure possibility. Of course, it could be a problem of the not proper preparation. Of course, for zirconia, it's a really important part of the preparation, because the zirconia is a let's say rigid material. It's a strong material, but a rigid material. So in case of the cementation was not proper, or the preparation was not proper, and the bridge can move just slightly in the patient mouth, or it's not supported from everywhere, every surface from the dies, it will be react the zirconia again with micro cracks, and it can develop that crack until the bridge will break completely through. Or, for example, the dentist can also make mistake with the grinding in the patient mouth. It's also possible.
Right. So before winding up our session, any takeaway note for our participants?
Excuse me, once again, please.
I'm saying that before winding up today's session, do we have any takeaway note for our participants?
Of course, water cooling is necessary in every cases. It's obligatory, necessary to do that. In our opinion, we had to grind as less as just possible. So we have to reduce grinding the zirconia of the zirconia material if it's possible. Sometimes it's not possible, I know, but then it's an important thing to work with water cooling with turbine, for example.
Right. Thank you so much, Mr. Balazs, for joining us and giving us information. And I'm sure that all the dental technicians and all the participants who have joined us today would have gained a lot from your information.
Thank you very much. Thank you too.
So with this, we are ending today's session. Thank you so much to all the participants. And we are ending the session. Good night.
Thank you. Bye-bye.